Hi 111. So in this video we're going to finish up with our discussion of these new kinds of transformations that we've been talking about with modifying graphs in the XY plane. And so far we've talked about vertical shifts and horizontal shifts by just adding or subtracting real positive numbers to either the function itself, the outputs, or directly to the inputs. Again, see the video on that if you need to watch that still. And then in the last video, we talked about vertical stretches or compressions, which we were able to accomplish by multiplying by a positive number, either a number bigger than 1 or between 0 and 1. And again, that made a stretch or a compression respectively. So in this last kind of transformation, we are going to talk about how we can flip graphs around in the XY plane, right? So far we've moved them up and down and left and right. We've stretched them, we've compressed them, but now let's talk about flipping them around. And this is what is called performing a reflection. And we're only going to perform two kinds of reflections. One will be reflecting across the x-axis and one will be reflecting across the y-axis. So let's start out our exploration here with, again, some motivation. So let's do some graphs. So let's choose a new function. Let's choose y equals the square root of x. So let's produce the graph of this function. So again, remember that the square root command is above the little x squared button right here. So access it by hitting second and square root. And now I need to put in x and close the parenthesis. Okay, and then let's enter the second one, which is going to be negative square root of x. So remember, don't use the subtraction key, use the negative key, right? So because we want to have the negative of something. So negative second square root x. And then we'll do one more. We'll do y equals square root negative x. So now notice that the square root actually has the negative inside of it this time, right? Square root negative x. Okay, so there are differences in terms of where we are applying this negative sign, right? In terms of orders of operation here. We're going to call this y1 here, which is the square root of x, in y2 and then y3. In y2 here, notice that the square root acts on the x first, and then that result is negated, versus what happens in y3, where the value of x is first negated and then the square root acts, right? So the order of operations here is differently. The negative is attacking different things here, right? In y2, the negative is attacking the result of the square root here, or the output, right? And in y3, the negative is directly attacking the x or directly attacking the input. Okay, so let's produce a graph and we'll see what this looks like. I'm still pretty zoomed in from my last graph that we did with our stretches and compressions. If I wanted to return to my standard viewing window, remember I can hit zoom, and then option 6 returns me to a 10 by 10 viewing window, so zoom 6. So here's y1, here's y2, and there's y3. Remember that the calculator graphs them in order. We can trace along these curves to help us remember which one is which. Remember, your calculator labels which one you're on up here in this top left corner. So I'm currently on y1, so the graph of y1, the graph of the square root of x, is this top half piece here, right? So if I were to make a little sketch here, y1 would look like this, right? It's the square root function. This is one of those graphs that I asked you to look at in section 2.3. Okay, so this is that graph that sort of goes up like that and sort of slowly goes horizontal here, right? It slows down up there. It doesn't grow very quickly. So that's the first graph. Now let's look at what y2 is. So arrow down to go onto y2. y2 is this bottom one right here. So y2 looks something like this. Okay, it's the same shape as y1, but now it's sort of in a different place, right? Again, if you're already sort of thinking ahead a little bit, we're thinking about reflections here, right? So you might already be able to guess how I've arrived at y2 from the graph of y1, but let's just hold on to that observation for a second. Let's look at y3. So arrow down to get yourself onto y3. If I just hit arrow down, notice I'm not anywhere. There's no cursor, right? And look what it says down here. X is 2.76 and y is nothing, right? That's because y3 lives completely over here on the left side of the xy plane over here, right? Its graph is entirely contained by this, right? By going that way, okay? And we can make that look a little bit more like the others. There we go. Okay, so if I use my arrow to go over a little bit here, I'll notice that over. Aha! Now there I am. I finally seen the cursor. It is starting at 0, 0, and now I see that on y3 I move back in that direction there, right? Okay, so what's actually happening between y1 and y2 and y1 and y3 is that we are performing a reflection. We're modifying how the inputs and outputs are being received or produced, right? To go between y1 and y2, what has happened? Notice that, remember, the order of operations says that in y2, I take the output of the radical, the output of the square root, and I negate it. So what that means is that you're negating all of the y values, right? You're taking all of what the y values were going to be and you're making them the opposite sign. So a graph that used to look like this, right, now needs to have y values that are the opposite sign. All the opposite signs. So this used to be all positive y values up here. Well, if I multiply all their y values by negative, it's going to look like this, right? So in y1 to y2, what we've done is negate all the y values. Okay, we've multiplied all of the y values by this negative sign right here, changed all of the positive y values now to negative y values. And that's why it looks like the graph has sort of been flipped across the x-axis, because all of those y points now have flipped down to being below the x-axis. Okay, and let's see what happens between y1 and y3. And I'll do this in a different color for you, just for fun. Okay, what's happened between y1 and y3? Well, notice here, if we think about what the negative is doing, it's directly acting upon the x, right? We have negated all of the x values, and then the square root applies, right? So what does that mean if we're negating all of the x values? Well, an x value that used to be over here, and then gets plugged in, is now going to be the x value that happens over here that gets plugged in, right, and gets that same y value, right? Okay, so if I take 5, for example, well, in this function I would be plugging in negative 5, right? Okay, which is kind of a little bit tricky, but we at least have to observe that we're negating the inputs here. So the positive x values now correspond to the negative x values, right? And you might be looking at this bottom one and saying, wait, that doesn't make any sense. I can't plug a negative into a square root. Well, look at the function over here that this corresponds to now, right? The x's that would be plugged in here, notice, are all of these x's, right? Those are all negative x values, right? Negative 5, negative 6, negative 7, negative 2, all of those negative numbers. When you plug a negative number into right there, right? When you plug a negative number in for x, that negative sign now makes it a positive number and outputs its square root, right? A positive answer, right? Okay, so reversing the sign of the number that you're plugging in allows us now to be plugging in negative numbers here and have it be okay, right? And so what's happened between y1 and y3 is that we have negated the x values, right? Okay, this negating the x values thing is a little bit more difficult to understand, but it results in what you can kind of see from geometry here, or from the graphs, is that from y1 to y3, this square root graph like this has now reflected across the y-axis, right? It's sort of, everything's been flipped over to this other side. Okay, and so we can make a generalization about what's happened here, right? If the negative acts outside on the y values, well, then you're negating all the y values and you flip across the x-axis. If the negative acts directly inside first on the x, then you're negating all of the x values and you flip across the y-axis. And let me summarize that for you here on the next page. So if we have a function, then if we take that function and modify it by putting a negative sign out front of the expression of x, right, like negative square root of x, then the new graph is the same shape as the original, but it's reflected across the x-axis, right? Okay, and we can say, here, maybe highlight this, reflected across the x-axis, right? Good. And that would be like our negative square root of x graph, which would be here y2, right? Alternatively, if we start with the graph of y equals f of x, and we instead say, no, I want to negate all of the x values, right? You replace the x with a negative x here, right? Then what ends up happening is you're negating all the x's and you reflect across the y-axis. Okay, and that would be like our y3 right here. Good. So what I'd like you to do to prepare for class to talk about these transformations together is to look over example 4 and example 5 in your textbook. Let me write this for you. So it doesn't have to be in red. Okay, so I'd like you to read examples 4 and 5 on pages, it's page 106 and 7, 106 to 107. Okay, and we will talk about combining these transformations all together and working on producing graphs of these things. And we'll have more example videos for over the weekend also.